Okay, so we're looking at mixed exercise 12 in the first year textbook, and it's on differentiation. So question 25, it's like an optimization problem, which are quite common, and later in this exercise you've got a few of those to try. But they've just given us really the bare bones, so that they haven't sort of, described the situation particularly. We haven't had to come up with a formula. They haven't really given much context to it. They've given us the formula for volume, which is in terms of R. They've then said find R when dV/dr is 0. Okay, so the first thing I want to do is find dV/dr. Now, one thing I am going to do for this question, which you don't have to do, is I'm going to multiply the brackets out. Okay, you really don't have to. So if you sort of tried this question and you just differentiated what's inside the brackets and then just left a factor of pi there, that's absolutely fine. And just in case you're a little unsure, I'm going to multiply it out. So if I multiply those brackets out, I'm going to get 40 pi r minus pi r squared minus pi r cubed. Okay, so I want to differentiate that. Okay, so just don't get thrown by the pi. Pi is just a constant. So those are the three terms that we're differentiating and just following the normal rules of differentiating. So if this was 2r, it would differentiate to 2. If it was 8r, it would differentiate to 8. So if it's 40 pi r, it's just going to differentiate to 40 pi. Yep. When I'm differentiating the r squared, I'm going to multiply by 2. So that will become 2 pi, and then I reduce the power, so that just becomes r. And here, when I'm differentiating the r cubed, I'm going to multiply by 3. So that's going to become 3 pi, and the power will reduce to r squared. Okay. Right. Then I want to find the positive value of r. Okay, so that sort of tells me that there's going to be two solutions. So find the positive value of r for which dV/dr equals 0. Okay, now I have actually got a quadratic here. Yeah, I've got an r squared, an r, and then a constant term. So this is a quadratic, so I will be absolutely fine just to put this straight into my calculator, which is going to be the easiest way to do it. So let me just rewrite it in the standard order. So there's my r squared, there's my r, and there's my constant. So yeah, you would be, and you might also want to, because we've got the minus there, you might want to multiply the whole thing through by -1. Basically, you are absolutely fine to put that into your calculator. Say A is -3 pi, B is -2 pi, and C is 40 pi. Yep, and I think your calculator should cope fine with that. And we're expecting two solutions to that quadratic, and we just want the positive one. The other thing I could do, though, so say you'd lost your calculator, is I could factorise again. So I'm going to take a common factor of pi out, or even just cancel the whole thing through by pi, actually. Why not do that? That's a bit easier. Okay, because it equals 0. Yeah, so specifically now I'm just looking at this quadratic I'm solving. So I could just cancel the whole thing through by pi. So this is just if you're keen to try it without a calculator. And then I always think I would multiply through by -1 just to make it a little easier. Oh, in which case that would be minus. Oh, that would be minus. And I'm going to assume it factorizes. So it does, it's got to be 3 and r. So what could we have? 5 and 8 wouldn't work. 4 and 10 would work. So if I did 4 there and 10 there, I could get plus 12r. Oh no, sorry. Right. Okay, so I could get, yeah, so if I put 4 there, that's going to give me 12r, and then that will give me minus 10r, so that would give me the 2r. Okay, but you are fine, unless it clearly sort of mentions, show you're working, which it tends not to with quadratics. You would be fine just to put that into your calculator. So my two solutions are r is 10/3 or r is -4. Well, they told me to go for the positive one plus r's a radius, so it can't be negative. And then again, with any question like this, just make sure you have finished it off. So although that was the hard bit, they wanted the value of v. So I just need to go back to this formula here and substitute 10/3 into that. Okay, so, and that I can definitely just put into my calculator. So V is pi times 40 times r minus r squared minus r cubed. And better to use r is 10 over 3 rather than rounding it to sort of 3.3 or anything like that. Okay, and we'll just quickly stick that to my calculator just so we can double check our answer. So 400 over 3, that's 100 over 9, minus 1000 over 27. Okay, so if I've typed that in correctly, I'm getting 267.6. So generally we round to 3 significant figures. I'm assuming we're in centimeters. I'm just going to put, oh, sorry, I didn't see. Keep doing that. Right, so, and we're in centimeters, so that would be centimeters cubed. Okay, if you put well, we'll check that it's actually the right value, but assuming it is, if you put 267.6 as your final answer, you should be fine. Okay, so let me just double check. As are the same thing. So 2,300 times pi divided by 27. Yes, it's give us the same answer. Okay.